Hi and welcome to the 2017 Paper 2 Junior Cert High Level Question 2. Now this question has two parts to it. First part, part A, is a 10C. I'd suggest you try pause this and draw it yourself. When you come back, we can look at how it's actually done. If you want this set of notes with the answer built in, just send me on an email at shanetroy@gmail.com. That email is also in the description below. So part A here is asking the diagram shows the line segment AB that's drawn on the page for you. And you're asked to divide the line segment into 3 equal parts without measuring it. Okay, and very important, you need to show all your construction lines clearly. This is quite simple. It's one of the constructions you have to know. If you draw a line at any angle, okay, just look like this, okay, a straight line, with your compass, okay, measure equal distances. Now it doesn't matter, okay, spread them out so that looks down just by hand guesstimating, okay, but obviously in paper you'll have an actual compass. So that's 3 equal segments. Now you draw a line from the third segment to B, okay, and then a parallel line from here to here, and a parallel line from here to here, and that should be in 3 equal segments. So again, it's pretty easy construction. But you need to know the different constructions, and I suggest you learn more and practice them. They are handy marks. So it's 10C there for that. Okay, and that's the answer just built in there, just done separately. And don't mistake, I see often people in an effort to be tidy, they rub out construction lines, or they for some reason do it in pen. Okay, you simply do in pencil so that if you do make an error, you can easily remove it. Okay, so that's part A. Now part B here. This is tricky. You're looking at this in general, but it's a 10D scale, so it's a good chance to pick up maybe the low partial or mid partial. I'll go through the diagram below. Shows the rectangle ABCD, so A, B, C, and D. You see it's split into equal segments. A, B, and CD, so the bottom length here and the top length, are divided into 5 equal parts. Some of the endpoints of these parts are joined by line segments, as shown below, to give it 2 shaded regions and an unshaded region. You're then asked to find the percentage, so multiply by 100, of the area of ABCD that is shaded. So I'm going to go straight to the answer here because I've already done out. Okay. Now remember, each of these line segments here, okay, we're going to call little a. Okay, so little a, little a, little a, little a, and little a. Okay. I'm going to call this difference here between the height, I'm going to call it H. Okay. Now, so I've said that there, so the length of AD be H, and the length of AB be 5A. So 5 times A. Now the full rectangle, the area of the shape ABCD, is 5A, so the length times the breadth, which is H, so 5A times H gives you this expression, 5AH. Now we're looking now at finding the area of the shaded region. So I'm doing them both here. So if you look at it here, if I draw a dotted line, that particular little smaller rectangle has an area of A times H. Okay, so A times H. This second part of that shaded region is a triangle. It's a right angle triangle, so half base by height will work. So it's a half, let's see now, half 2A, A times A, we'll put 2 in there if we can, times H. Now the half cancels the 2 or 2, multiplied by half is 1, so that's described as AH. So that larger shaded area is AH plus AH, which is 2AH. Have it done there. Now the smaller shaded region also has a rectangle here. Again, that's A times H, plus a smaller triangle. The base is just A, so it's a half A times H. So all in together, that smaller shaded region is 1.5 AH. Now we've no numbers here, so we're dealing in general terms. All the shaded regions together is 2AH plus 1.5 times AH. That's 3.5 AH, which I've detailed over here. So our final bit now to find the percentage of shaded is the shaded area divided by the total area. That's 3.5 AH divided by 5 AH. The multiply by 100 to get percentage. So the AH will cancel. You're left with that fraction. Okay, multiply that by the 100 and you get 70%. If you look at it for the what I've called the bullshit meter. Does that look, the shaded region look like it's almost 3/4 of it? Yeah, it's believable, so I'm fairly sure that I've done things correctly. Always be willing to check look at your numbers and go, if they don't make sense, if they just seem, that can't be true, go back and check your workings and make sure you haven't made an error in calculation, which is usually what happens. I think that's the end of question 2, so thanks very much.